Good morning, good afternoon, and good evening, everybody. Thanks for joining. Uh, Dave Schultz, Frank Galuska, and Kevin Jones here from Spruik and Ectobox, respectively, here to talk about the UNS. Thanks for joining us. Really appreciate you being here. This is going to be the second session on talking about building out a UNS, and indeed, this is actually going to be part 2A. There will be a part 2B, which I'll get to. As a form of introductions, I'm Kevin Jones, CEO, Chief Strategist at Ectobox. Frank and Dave, real quick introductions for yourselves, and then we'll get going.
Yeah, Frank Deluska, Senior IoT Engineer at Ectobox.
Dave?
And David Schultz. I'm a solution architect and a principal consultant with Spruik Technologies.
Awesome. Cool. So we're going to get into a deeper dive into designing UNS, and we're going to talk about what it is and then get into connect, collect, store, analyze, and visualize, that process of actually connecting to a machine, pulling the data out, and then using the UNS in that whole process. We previously talked about planning out the UNS, some concepts, some very basic concepts. And for this session, we were planning on getting to the machine, connecting the machine, and pulling the data through the UNS, displaying it in the Canary Labs historian. But we stepped back and thought, well, actually, and this was by Dave Schultz's suggestion, which was a great one, there's a big gap of understanding out there about some of the deeper concepts within the UNS, within the Unified Namespace. And it makes a lot of sense to cover that a little bit more deeply. So what we're going to do is to split this webinar into two parts. The first part is going to be that deeper dive into the UNS today, some of the concepts, ideas, and plan out some more details about what our UNS is going to look like as we go through this series of webinars. And then the second part, we're going to get into the deeper connectivity stuff. Frank and I are going to do a video next week, and then we're going to push that to YouTube and let everybody here know about that video. And that's going to be probably a video about twice as long as this one, because we're going to be showing here's how you connect to the machine, here's how you use Ignition to do this, here's how you set up the basics, fairly quickly set up of a data broker, and then getting Canary historian to subscribe to that data and pull it. And we're going to actually see that UNS in use that we're talking about and starting to build out today. We wanted to separate it because otherwise we'd be doing an hour and a half, 2-hour webinar, and I think that's pretty long for a single sitting session. So with that said, we're going to get to it. This is a kind of the basic idea of what we might be building out using our cappers. Just grabbed an image of a capper, a bottling line capper off the web. But when we think about UNSs, the big question is, what is a UNS? And from my perspective, when I think about a UNS, it's really about being that single point of access within a manufacturing plant or within an enterprise for sharing data across the whole organization. As I've heard Dave explain it in other sessions and other conversation, it's an endpoint through which all the data flows. Any data or event can be made available in the UNS, and other systems can come in and get or consume that data. And that data can be of a machine, of some kind of event from a machine, or from an operator, or from a maintenance person, or from any kind of transactional system like an MES, an ERP, a CMMS, etc. Dave, is there any more that you want to add to that general definition of a UNS?
Yeah, it's I always go with the one that we always talk about, just reinforce it. It's that single source of truth for all your data and your events. Meet that more manufacturing focused, and it's also the structure of it. So we want to make sure that when we're presenting these, the semantic data models or what are used to build a UNS, is that we're also presenting that information in a place that makes sense within the hierarchy of the business. So if there's some sort of manufacturing type data that exists within an ERP, we're going to have that model that's part of an ERP, an ERP namespace or an ERP location, so that there's an understanding of what information belongs where. So that's that structure that we want to make sure we include as well.
Good. So that's a good segue to the next thing that I wanted to cover very briefly is Some people might be asking, well, what is a namespace? A namespace is kind of like what you've been discussing there. It's a way to organize information within this whole hierarchy. I think of them as, they are the ontology or the taxonomy of an organization. It's a way to identify the specific things that you care about, the systems you're using, the data that you care about, the machines, everything else that's going to be in this organization, identifying the relationship of them to one another, and then the place where you can access the information, the attributes, the properties of those devices. Is that reasonable explanation of a namespace? Anything to add?
Yeah, absolutely.
Yeah, good. All right. So with that said, then some examples from past sessions that we've done. I'll just expand here a little bit. These are some UNSs that Dave has built out over time. Hopefully you can see this reasonably well, where you've got the view of a site. Well, let me back up. Again, just real quick review. When we think about the UNS concept, the taxonomy that we're using comes from ISA 95, and that is to organize things by enterprise, site, area, line, and cell. So we're organizing everything within that kind of structure, kind of like a tree, leaf, or folder structure, as you can see here. So we have an enterprise, site, area, line. Well, here's a line in this one, and then the various cells. And then we organize the data within these, and we'll get into that in a little bit more detail.
Yeah. I think it's important to understand that this should really follow the structure of your business. So if there's a business unit or you refer to these things differently, we commonly use the enterprise site area line cell as one, but there's certainly nothing that precludes you from just having, say, a process unit that's a part of your hierarchy. So it's meant to represent how you organize your business itself, not necessarily follow this.
Yeah, this enterprise site area line cell kind of structure, I think a good way to put that is it's not law, it's a guideline.
Exactly.
And then vary from that to suit and fit your business.
Yeah, the goal, of the unified namespace is what Dave said earlier, is that a single version of the truth and have everything be organized and easily accessible. So, yeah, just kind of that's what ties into what Dave was saying, where it depends on how the business is set up.
Mm-hmm. Yep, makes sense. So let's talk a little bit about some of the types of namespaces out there. We'll get to the point of looking at the namespace that the UNS that we started to build out last time. But, oops, a little big. There you go. There are several types of namespaces: edge, hierarchy, functional, and informative. I don't think it's represented there, but Dave, do you want to talk about each of these types of namespaces and their use and value?
Absolutely. So within the functional the edge namespaces, sometimes I'll call this an asset or an equipment. So these are some of the models that we built during our last demo. People have a pretty good understanding of what these look like. This is largely going to be comprised of the tags that are included within your PLC or whatever your control system is. And it's that raw data, things that are, changing all the time. So, what I have examples of here is, I always like, going back to my motor and pump example. So you're going to have data that's coming from your edge namespace, and you're now going to compile it or get it put together in a semantic data model. So instead of having raw tags, let's bring it together so we at least understand what is the asset, what is the equipment, what does this edge namespace look like. So when we're referring to it, that's the model of the asset or equipment that's easily digestible and viewable, that somebody knows, oh yes, this is all of my motor data type thing. The next piece that you get into is more of that functional namespace. And so functional, think of it in terms of something that is making a calculation, or it's more of an event. So I have in here an OEE namespace that is, we'll be reading values from my edge namespace, doing a calculation on what OEE is, and then presenting that information back as an OEE namespace. So, I'll have things like my current run or shift, the amount of time that's been production, if I've had downtime, how long that downtime event is, what my APQ values are. If I'm looking at an existing production run or a batch, then I'll have all of my counters for the the batch information or shift of how much material has gone in and out of it, that type of thing. Or I'm going to have a material movement. So if I'm bringing in batches of material, I may start off a particular production run working with one batch of material, but then that changes throughout, so that material namespace will get updated. Again, the idea is that we're going to have the current state of the business all available in real time. I'll finally take these edge and these functional namespaces and I'll put them into a hierarchy so that I might have a line or a cell namespace that has some of these other namespaces that are built into it. And this becomes part of this data governance piece of that thou shalt versus thou may. It's that you will have a CMMS namespace. So there's a maintenance work order that you need to do. You will have that part of your line in your cell. But if there's other information that that should be included, that you have a little bit of latitude on doing it. So there's some ways in the various tools that we use to build a UNS to account for that. And then finally, you just have the information, or the informative of, this is information that I'm going to display, so that when I'm looking at say my visualization tool, a screen, a window, whatever that looks like, it's that when you are viewing it, you're viewing it in terms of what your role is within the organization. You're going to look at it in the context of where are you within, say, this particular location, or sometimes within the context of an event. So for instance, if there's an alarm event that's occurring on my production run, when I open up my visualization, I'll want to see some of that information of, what's the critical information. I need to do something with it. And so I utilize these common informative namespaces to present that information. So that's kind of a good way to take a look at some of the various namespaces that are out there. But it's not just the edge data. There's a lot of different namespaces we can do around edge, functional, hierarchy, and then of course how we're viewing information.
So what I'd like to do is to just pull up one of the examples from prior discussions and sessions that we've had and see if we can pick out some of this here. I'm trying to remember which ones to use. A little bit of on-the-fly work here. Actually, the cell overview I think might be. We don't have edge in here. I think maybe you use parameters here. But if we were to, this is a decent one here. This. Cell overview to start with?
No, I think a cell is a good place to start. So in this, and I'm using this is a tool called Ignition. So this is from Inductive Automation, but you can always build these data models. There's a number of different tools that we talk about on here to do these types of things. So you mentioned Factory Studio earlier. There's Neuron. There's HiByte. Several tools you can use to bring this semantic data together. So I just want to make sure that people are aware that you don't have to just use, say, Ignition for it. It's just happens to be where these got viewed. So within that, you're going to have parameters. Parameters to me are your static data. That's going to be, if you noticed here, there's an area that there's a site there. That's because if you want to do some data ops or some data analysis, you'll be able to know exactly, okay, I'm looking at some motor data. Well, where's this motor located in my overall process? What is the manufacturing area type of thing? And then of course you can still use it like the line number. If I use parameters for line 1 to line 2, it's there. But I'll also bring in things like an asset ID. And the asset ID is now going to be part of, say, a CMMS work order that's been created, is that when I go retrieve or create a work order for this piece of equipment, I'm going to consume that asset ID as a part of that process. And what that allows you to do is when you have an instance of a model, this gets updated, and now you can utilize and reutilize all the underlying code. That becomes more of a programmatic application of it. So the intent is you build one, and now you just deploy it across your enterprise.
So then thinking about some of the functional namespaces here, just looking through and spotting some of them, for this cell under CMMS, this could be a functional namespace for a maintenance work order where we would have the system, a maintenance work order could be generated, that information available here in this particular namespace, and I can bring up another screenshot for that. And then that information goes to the CMMS system. Somebody gets an alert. Hey, they're going to go work on the machine. Then they have gone back into their CMMS, entered some information to say, hey, the work order is done. Here's what I did. That information then can be published back into the namespace, and then the MES or other system can then subscribe to that data and display it to the operator on the screen. And so that this UNS then, it's a good example of where the UNS becomes that single version of the truth, and this functional namespace is that for the CMMS maintenance work order, then becomes the place where you can have that event and maybe some calculations be processed, published, and available for anybody else or any other system to consume. MES is another good one for manufacturing work order, or no, I guess there would be an ERP here somewhere. The Run OEE and Shift OEE are other good functional namespaces for this as well. On the right path?
Yeah, absolutely. So really what that CMMS namespace is telling you is that if I have a downtime event, and I can see that because my both my edge tag is saying, hey, you're down, it's also tracked in my OEE. Now you can see that there's a, excuse me, the state of the equipment is, whatever, it's electrical, it's mechanical type of thing. I may also want to know, is there an active work order on that on this particular piece of equipment? So, say that I have there's a jam in my caser, is what you can see here, is that I will now know that I need to, or that I can see in real time if there's an active work order. So it's not just, hey, look, you have a downtime event. Is something happening with it? Oh, great. There's a work order that's associated with a maintenance work order that's part of my CMMS. All this information is being consumed by all the other systems. So those updates, as these events occur, that gets stored so people can see, okay, I had this downtime event. Who is the technician that's working on that? When was the start time of that event? When was the maintenance work order created? You now start getting all these time blocks where you can go back and analyze the data, and it's all ready to present to you. You can readily consume it rather than having to go out into all these various systems of, instead of making a query to my CMMS, I have that information that's all been presented and historized and stored in other systems.
Mm-hmm. So then, just getting back to this diagram here, we've covered edge, hierarchy, and functional. What about informative?
Yeah, I don't have an example of an informative namespace that we presented, but as I mentioned earlier, or at least in some of those other visualizations we've had. But the way to take a look at something like this is when I'm drawing out a screen. So if people are familiar with developing SCADA screens or HMI screens, oftentimes those have been done statically in the past. So whatever information I present on the screen, every time you open that screen, that's exactly what you're going to see every time. But you might have some differences in the equipment that exists there. So say you are in a factory where you now have equipment that moves around. What you will do in this case is that mobile equipment will now be presented in the hierarchical namespace of, I now have, I'm now using this piece of equipment. So when you open up that view, it will, through usually these are done with some scripting, it'll take a look at what's all of the equipment, what are all the assets that are associated in this, say, particular line, because I'm now looking at a line view. It'll return those, and it'll present the visualization of that piece of equipment within your manufacturing line visualization. And that's how you'd want to use the UI piece. Or you have some variation on, say you're in an extruder process where in some areas, my extruders have different numbers of blenders, or I'll have different numbers of zones for measuring temperatures, those types of things. I'll use a UI tag to build up what exactly does that look like, so I can build one screen, but then it's informed through this UI namespace, because that now tells me all of the equipment and the underlying asset model of that line.
So is the idea that you could have different ways to organize the data, but you've got one consistent model of the data that you want people to see,
Correct.
And that's what you're providing there. Correct.
Yeah, absolutely. Or in the case of the alarm or the HMI, the alarm namespace is just something that I just need to visualize an alarm count on on a banner or on a header of my view, so I can tell how many active alarms do I have? What are those priorities? Or in HMI namespaces, just this is some of the information that gets displayed. It's not necessarily part of my asset model or my edge information, but I know these need to get reused, so it becomes a configuration point as well.
And I know you use even a dashboard namespace too. I think I've seen that
Yes.
in some of
Yeah,
your work.
absolutely.
It's the same idea, just a different visualization, a different way to display the data. Maybe it's the same model or a slightly different model, and then you're organizing it into a namespace so that. Go ahead. Yeah. So then, Frank, any thoughts to add to this?
Yeah, I mean, as far as what we were just talking about with the informative namespaces, that as a IoT engineer, that's also something that really helps speed up development as well. Then you're not making dedicated screens for every single thing. It's more of a template that's sort of all interchangeable and model based and not static. So that's another pretty huge benefit to this type of architecture.
Thinking about a lot of the how the world is, at least in some ways, moving away from these discrete connections with the Purdue model, et cetera, and finding those discrete connections to, in many ways, be expensive and limiting. Moving to a slightly different model where you can define information, structured information in one place, and then have access to it in all kinds of different places. And that goes even as far as just exactly what you said, Frank, being able to do that for displays of information as well. Makes a lot of sense.
Mm-hmm.
Let's move to the next.
Really helps. Sorry, it really helps. Having everything flow together. Like Dave was saying earlier, you have your edge namespace that you use that information and feeds into some of your functional namespaces, and then you combine that with CMMS data and ERP data to your hierarchical namespaces, and it really just gives you that that full view of everything top to bottom.
Mm-hmm. Right, makes sense. Good. All right, I think it's time to move on to doing a little bit of planning for the project we've been working on. Last time we looked at this edge namespace for the capper with heater temperatures, pressure sensors, etc. And I did a little bit of modifying this on the fly. What I think we should do here is to talk about this a little bit more. So I'm going to move over to a Word document where I have this basic layout already visualized here, and let's talk a little bit about what we might need going forward. So in this webinar series, first thing we're going to be doing is to connect to the machine directly, pull that data out, get that data into the unified namespace, and make it accessible to other systems. So getting that raw data, the place to put that raw data is the edge namespace. Frank, does that make sense? Is that what we're going to be starting with next week when we do that detailed connectivity, connect, collect, store process?
Yeah, I typically like to work from bottom up. So start with getting your devices connected, getting that edge namespace defined, and getting that data, and then like I was saying, see how that feeds into your other namespaces, your functional namespaces, and into your hierarchical namespaces.
Right. So then that means that we would be taking this edge namespace and then filling out essentially. Let's do this so we can see both of them at the same time. Then we'd be putting our heater temperature here, the pressure sensors, potentially the limit. Oops, if I could spell limit switch information, etc. Am I going in the right direction here?
Yeah. Again, kind of like like we were saying earlier, anything that's really coming off of the machine, telling you information about how that machine's running, the process it's working on. That's all kind of part of your edge namespace.
Right. So then, guys, if I'm thinking about then building out the solution, so the next session, I think we talked about connecting to or setting up an MES. And as we all have talked about many times, some of the first things that manufacturers will ask for are downtime, OEE, work order management or work orders, and then scheduling for that. So if we were to think about the work orders, that work order, where does that fall for us? Let's kind of go through this example so that we can really illustrate the basic ideas. Does that work order fall under the capper or the line? And situationally dependent, but where would we want to put it for what we're going to do?
Yeah, so if we're going to follow the ISA 95, where your work is done is going to be at the line level. So the cell is just a piece of equipment that is part of a line that they're all manufacturing within the context of a work order itself. Now, I realize in this example, sometimes you'll be finishing off one work order and you're going to be starting a new production run on a cell, but for all intents and purposes, within the ISA 95, that work order really exists at the line level. So in the context here, this is going to be the work order that is currently in production, not necessarily all of the work orders that are available from the ERP. So it's important to understand that when we have what's commonly known as a work order table, that's more of either a site or an enterprise type model. But the actual work order that is currently in production, there will be a namespace that's going to give you the information of the work order number. What is the SKU of the product that we're making? What are some of the specifications? So maybe there's a standard rate or a schedule rate that's going to be associated with that particular work order. What are the material movements that are associated with that type of thing? So, that's some of the information that will be included in that work order. That's part of a line space. Again, it's what's currently on the line itself.
Good. Am I following along here with what I've got on the screen?
Yeah.
Okay, cool. So then what would be next? Would we want to talk about downtime, OEE, what else, and where would that fall then?
Yeah, so going back to the other example, then probably the downtime and or OEE would come into this namespace next. So then, because commonly once we start connecting and collecting, storing, visualizing some of this information, now we're going to realize, oh yeah, I know that I have a downtime, but I don't know why I have a downtime. And that's where we get into some of the downtime codes and tracking of not just having those events, but it's the actual reasons why we're down. Those are, think of the 5 whys. Well, why did this happen? Why did that happen? And that's really going to be one of the very first questions of, wow, we need to know that of, why are we down? And then also we need to know why we're down. How is the line performing just in general as well? I know what, my in-feed and out-feed is, but am I actually maintaining the production that I'm expecting? So I should be, operating at, so many pounds per minute or so many pounds per hour of a material product. Is that working? So I would bring in some downtime and then extrapolate that a little bit more and get into the OEE piece as well. But that's, similar to where the work is done. OEE is going to be at the line level commonly is where it's going to be. So
then we can take the shift and run the different, I want to say versions, but different OEE values that we can calculate and run those at the line level also, right?
Yeah. So your run OEE, that's going to be more what I call batch leave. So within the current work order, within the current product that I'm running on the line, how is this particular product running? And then overall from a shift standpoint of what does that look like? How much material have I produced versus what I was scheduled to produce? So I have sort of my theoretical rate of, I should be getting this many pounds or this many bottles or this many cases loaded. Am I actually meeting that production target? So think of it in terms of batchly and shiftly.
So then for our CMMS work order, maintenance work order, would that be then at the cell level?
Mm-hmm. Yeah, so for this, it's if there's a work order that's presented to the cell itself, so as the example I used earlier, it could be at the caser, it could be at the bottler. That's where you're going to have a maintenance work order that's associated with a particular asset. Now, most CMMS systems will have an asset ID that's associated with the line itself. So it may be just an overall, we're repairing line 1. So you'll have a CMMS or a namespace on the line as well.
Okay. So then what are the different kind of situations? Can you dig into that a little bit more? Why at the line and why at the cell?
So why you would have it at a line, or excuse me, at a cell, is that there's a particular piece of equipment that's now, I'm in a downtime state where it's a mechanical, there's an electrical, I need somebody to come out to the equipment, a technician, and I need to do a repair. So that's the situation in the event where you would have something at the cell namespace, as I've done in my example at the, I think it's on the caser itself, there's now a jam that's associated with it. Somebody needs to come out and clear the jam from that. So there would be a complete maintenance work order namespace that would be created for that particular event. You can also schedule maintenance on a particular line. And this is one of those, it's, from an availability standpoint, we've now removed this particular line from production. We're going to have, several technicians, or we're going to go through, and it's time to do some kind of maintenance. It's, we're due for, line maintenance as part of our overall, asset health management. And then there's going to be a work order, or, there could be several maintenance work orders that are associated with that particular line. And you would have that present at the line as well. So, I think just from a rule of thumb, one is that there's an immediate need for something to be fixed. One is more of it's just more of a preventive maintenance type of thing, or a condition-based maintenance type of thing. We've run so many pounds of equipment, we know we need to take it down, or we're going to start losing efficiency.
Good. So, Frank, any thoughts, anything to add to this so far?
No, I think what what Dave was covering there all makes sense, and I guess my one sort of add would be that if you have maintenance issues on a certain aspect of the line, those could be critical to the operation of the line itself, and kind of have it roll up that way.
Fair. The for an ERP and the manufacturing work order that we would get from that, this work order that I have here at the line, is this, well, I guess stepping back a little bit, is what we have here a decent start for a good structure for us to think about as we build out this this UNS with connecting to the various systems?
Yeah, the last thing that I mentioned was just material movement. So what raw materials are coming in. The example I commonly use in my demo is I have a juice factory, and I'm in the process of I'm making some juice. So for my raw materials, I have some sugar, a sweetener. I have a color, I have a flavor, and then I'm also going to have a consumable of water, and I'm going to have that information, or I'm going to have lot information and quantity information. So there's a material movement of material that's coming in. And then I'm going to have material of have a material movement of product coming out. So now that I've brought all these together in a tank and I've mixed them all up, after some period of time, I'm now going to discharge those to a storage vessel. So I'd have material in, material out movements that are capturing that information as well. So within the context, and that, if you think of it in the timestamp or the time slice of the actual production of this particular, this product, it's more of the material information, because there might be something that occurs, like say I change from lot of one sweetener to another sweetener, that may change the overall, impact the performance of some piece of equipment. This is very common where, if one of the challenges you have is that we run into production issues, but we don't know why. Well, sometimes it's because there's a material source that comes in. Well, if you've been now tracking that information in real time and have been consuming it, you can very easily and readily go back and start taking a look at how do our different suppliers perform on particular lines. And that's information that you don't have to go out and start pulling through all these various systems. You've been capturing this information from our UNS. You're consuming all of this information, disparate information, non-normal, and contextualizing it, presenting it at the same time.
Yeah. This is a really powerful tool to kind of getting back to what we started with at the beginning, is to provide that single point of access, that single version of the truth, data organized as the plant operates, ISA 95 being a guideline, not a rule or a law, and then organizing things within a hierarchy, and then making this data available to all the system, any system, anybody who wants it. And setting patterns for the whole organization in a single place, rather than letting people kind of have their own way, where we see a lot of problems with companies that will build systems and do integrations in an ad hoc manner, and they end up with a huge mess and a lot of negative, what I call technical inertia or technical debt, negative inertia or technical debt. And it becomes very difficult for companies to unwind that, especially as the technologies become old and they need to be upgraded or replaced. And defining this taxonomy or this central taxonomy or ontology right at the core of the business, and it represents the business, and then organizing it in the ways that Dave and Frank are talking about, it's huge value. It makes things much, much far more simple and easy to maintain and connect to and integrate with and share, and then enables that innovation. Dave, anything else?
Yeah, no, absolutely. And and I think the whole point is now we've presented this in a real-time fashion of a real-time snapshot. Now it's starting to get that information historized, so we can go back and start doing some analysis on it as well. And I think that'll start help to, to sort of bring this home as far as why are we creating all these data models and presenting this information in a common structure will start to make more sense, because you can start, once you pre-process information and get it available to other systems more readily, it makes it much easier to do your analysis because the information is already, it's pre-processed. One of the biggest challenges is sometimes is what's called ETL, that's that extract, transform, load. We're taking care of a good chunk of that just through the architecture of capturing the state and the events of all of the equipment and all of the information that's part of your manufacturing process.
Right. Another flavor of that I would add to it, a couple of them. One is that information is data with context, and we are adding that context. We're taking the information from the machine and contextualizing it with that information being fit into the structure of the rest of this data. So it then starts to become information, and you can absorb or subscribe and take all of this data and then be able to have that context, have the relationships with the data working already fit together, so that you can draw correlations between what happens in one system to causing an issue in another system. And the other idea too, I think that's some of what you're referring to when we get into analytics up to the level of, data scientists wants to start to consume the data, anywhere between 60 and 90% of the work that data scientists do is to clean up and organize and connect or contextualize that data. A lot of that work's already done, so it's that much more straightforward.
Yeah, absolutely.
Any parting thoughts, Frank or Dave? I think we've gone through everything. I wanted to give everybody another opportunity to throw in a question or two if there are any. There were a couple comments about sharing screens and expanding, and I can only expand or zoom in so much here, unfortunately. Are there any questions from anybody? While somebody might be putting in a question, Frank, please go ahead.
Yeah, I was just going to say, I think it's important to touch on that, what we've been talking about here isn't platform dependent. We've been showing screenshots of Ignition and talking about, this isn't platform dependent. Anything that has the ability to, organize data, model data, this is simply a way of doing that, and a philosophy behind, why that is important. And then once it's, out into a data broker or, at any other centralized location, that it's readily available to those other sources that, we were talking about, such as historians or ERPs or whatever.
Yeah, awesome. Great thought. I forgot to mention that. That was a good one. Thank you. Dave, any final thoughts?
Yeah, so there's actually a question that just popped in of how do you think the data from different levels? And I understand what you mean by that is, that's the whole purpose of, say, using an IoT platform to start bringing in information from other systems. So we didn't really touch on how we get at some of this information. We talked a little bit about PLC tags and connecting into those. Information from these other systems are going to be done through SQL queries or API calls, or there's some kind of endpoint where we're having to access that information, or flat file exchange, I guess, is a third variation of how we're getting that information. Well, those typically, that information where it's consumed is triggered off of some kind of event, and that's when the IoT platform that we're using to build the UNS would capture that information. So information that's coming from different systems that is not necessarily time-based, but maybe is event-based. That's how we bring together all that disparate information. So information that occurs at different levels within your structure, that's how that information is architected and presented. I hope that answered your question.
Good. Any questions from anybody else? Should we connect the warehouse to the UNS or part of the ERP?
So for me, I take a look at a UNS as more of a manufacturing system. So I would only want to take a look at a warehouse system once it's now becoming WIP. So I've received a purchase order from a client. I have scheduled that. I now have, and within my warehouse, I have called that information that I'm going to consume it at some point. I know what that looks like. Until I actually move it into the area or stage it, that's when I'm going to start using the information around UNS. That's how I typically use it. There doesn't mean you can't. This is all depends on your business. But for me, a UNS is really focused on manufacturing production. But you'll have people that will do it different ways.
Yeah, it doesn't mean that it can't be done. It's just a matter of what's the ontology you're going to build the structure, and then for how your operation works, whatever that operation is, and then you go from there. Frank, go ahead.
Yeah, you could have a whole separate namespace for your warehouse, right, and have all that information sort of part of the larger UNS, but also in its own sort of subcategory.
Mm-hmm. Yeah, good questions. Thank you, guys and gals. Awesome. Well, I think that wraps up this session. Again, we are going to be, we're going to be putting together a video for the connectivity, and then starting to utilize and implement some parts of this UNS that we have here, and then build it out over time. And in the meantime, if you want a link to our prior session, that should be already shared in this video, and it's also available on our YouTube channel. Apologies, I meant to mention at the beginning of the session that the prior session is available on YouTube. With that said, thank you very much. We will let everybody know when we will be scheduling the next session. It will be in April. It's just a matter of question of when we're going to do that. So thank you, everybody, for attending. Frank, David, thank you so much for your time. Really appreciate it.
Okay, my pleasure.
Yeah, thank you.
All right, thanks, everybody. See you.